Namaste students. Now we will discuss some of the important points that you have to remember while entering the practical exam hall. We'll start from resistance per unit length and resistivity of the material of a wire. So this in our lab we are providing an ammeter which is having a non-linear scale. So here the first line itself is 0. No doubt it is written. But the next line is not 0.1, it is 0.5. So there is a sudden jump from here to here. There are no readings between 0 and 0.5. There is nothing like 0.1, 0.2, 0.3, etc. But what about the next line, this one? This is not 1, that is 0.6. So from here onwards, there is an increase of 0.1, 0.6, 0.7, 0.8, 0.9, 1, 1.1, 1.2, 1.3, 1.4 like this. So there are no divisions for 0.1, 0.2, 0.3, 0.4. So from 0, you have a sudden jump to 0.5, then 0.6, 0.7, 0.8, 0.3. So it is a non-linear scale. So you have to take care of it. It is written here in this diagram. So it is like we have here 0, this one, and 0.5, and 0.6, 0.7, 0.8, 0.9, 1, 1.1, 1.2, 1.3, 1.4, 1.5, so on. So this is a different type of scale. In all the other ammeters and voltmeters, you have a linear scale. There is no difference in such readings. So here only this, in between these two, there are no divisions. So take care of it. And for all the experiments, we are using digital multimeter as a voltmeter. So a multimeter can be used to measure voltage, measure current, DC current, AC current, resistance, and all these things. And a single device can measure different quantities. So when this knob, you can see a knob here, you can turn it. When that knob is turned to this portion, you can measure voltages in DC values. So because it is written here, so there is a volt symbol like V and a straight line. Straight line indicates that you can measure DC voltages. Suppose you want to measure AC voltage, you have to connect it here because here is a sine wave. So if it is written like this, then it is AC. And if it is written like this, then it is DC. And you can measure current here. But we are using this multimeter only for measuring voltages in our lab now for your experiments. And that is DC voltage. So turn this knob to 20 volt DC. So 20 volt maximum. That is range. 20 volt range means you can measure any voltage between 0 to 20. And in most of the experiments, our reading finishes before 20 itself. It lies within 20 itself, so you need not worry. So keep it within 20 volt for every experiment. Don't forget it. So there may be a different type of voltmeter given. It may be like this way also. So this has to be turned to this line, 20 volt DC. So other things, of course, you will use it as an ammeter, voltmeter in higher classes. But now you need not worry. So you can use it to measure resistance also. But now for the time being, we are using it as voltmeter. And we are measuring maximum up to 20 volt, within the 20 volt. So just put it into 20 range voltmeter DC. Okay, so here like this. So you have to turn this from here to here. So you have to put it here, right? And it also has a positive and negative, red positive, black negative. Okay. And the difference between the two units, resistance per unit length and resistivity. Don't get confused with it because it is very simple. Here itself it is given resistance per unit length. That means it is resistance per unit length. That is ohm per meter. So the sentence itself says, so this is ohm per meter, whereas resistivity, it is ohm meter because resistivity is RA by L. So if you know how to do this, this is ohm, area is meter square, this is meter, so 1 meter gets cancelled. So finally remaining is ohm meter. So resistivity is ohm meter, resistance per unit length is ohm per meter. Don't simply, this may be a Viva question, so don't get confused for such very simple things. It's very simple. Resistance per unit length, ohm per meter. Resistivity is ohm meter. So this is one area where you usually go wrong. And finding the slope. Remember, whenever you are finding the slope, for example, in this experiment, you do the experiment for different voltages and different currents. You set some voltages and find out some currents, and then you draw a graph like this. Voltage is always along x-axis in all the experiments, and current in amperes is in y-axis. You draw it like this, and you choose a suitable scale and draw a graph. Now, always this is the y-axis difference. So this line, this length of the triangle, here it is written A and here it is written B. There is no restriction that you have to write ABC like this way only. You can write it anywhere. But once you write it, AB is along y-axis. So AB is responding to y scale. What about BC? BC is the change along the x scale. So BC into x scale. You know that y by x is the slope. So this is the slope. Slope is always y-axis change by x-axis change. Delta y by delta x is slope. So AB into y scale, BC into x scale. And if you want to know what is the change along y-axis and what is the change along x-axis here, so you follow only one method. So I suggest you to follow this method. Once 1 unit, 2 units, 3 units, 4 units, 4.5. 4.5 units along y-axis, and what about in x-axis? 1 unit, 2 units, 3 units, 4 units. 4 units into, so here 4.5. What is the value of 1 unit? 0.2, 0.4, 0.6. That means 1 unit is 0.2. So 4.5 units, 1, 2, 3, 4, 4.5. 4.5 into 0.2 divided by 4 into, here there are 4 units, or you can call it as 4 centimeter. It is left to you. Into 0.5, 1.5 means this difference is 0.5. So it is 0.5. This is what you have to calculate. And when you calculate it here like this, you will get I by V, not V by I. Because along y-axis we have current, along x-axis we have voltage. That is 1 by R. So if you want to get R, you have to do for 1 by slope. Because slope gives I by V. This is current change, delta I. This is delta V. So you don't get resistance directly here. 1 by slope you have to do. And that is, of course, you can calculate it here. You can see the values and try it once. Do it once before going to the lab, because just simply observing it like this won't give the answer. So calculate it yourself, compare it with this value. Whether it is correct or not, you just check it. And you will find all the problems when you calculate it, and filter it now only, and then go to the lab. So this is resistance. Once you get the resistance, all the resistance wires that we give in our lab is of length 15 meters. So resistance per unit length is 2.22 ohm divided by length is some 15 meters. So you will get resistance per unit length. You will do the same experiment in the same way for resistivity also, but you are not going to draw the graph. So for resistivity, what you will do is you use the same ammeter, same voltmeter, very simple circuit. Then you calculate you apply different potential differences, you will get different currents, or you set the current value and you will get some voltages. Once you get them, then you calculate directly R equal V by I. Once you get R equal V by I, calculate the mean value of R, add all the values and divide it by the number of trials. Then you substitute in this formula. Rho is equal to RA by L. Rho is equal to RA by L. R is equal to rho L by A. So A area can be written as pi R square. So R equal to, rho equal to R pi R square by L. So radius will be given. Remember, you substitute the mean value of R, 3.1, pi you substituted, pi, then mean value of R, 2.19. Then R square, radius is 0.2 millimeter, 10 to the power minus 3 meter. So this is milli, 10 to the power minus 3. But when you square it, you know that 0.2 into 0.2, 2 times it is written. What about 10 to the power minus 6? It is 10 to the power minus 3 whole square. X to the power m to the power n is x to the power mn, minus 3 into 2, minus 6. But don't mix it with numbers. Simply write it at the end. It is micro ohm meter, or simply write it as 10 to the power minus 6. So multiply 3.14, 0.2, that is the radius. and resistance, whatever you get, divided by 15, that is L. Write the answer into 10 to the power minus 6 ohm. Don't try to change this. If you are capable, change this to 10 to the power minus 8 or 10 to the power minus 7. That is left to you. But this is enough. So minus 6, why do you get minus 6? It is minus 3 millimeter radius square. So that is the answer. Okay, so here we are not going to draw any graph or anything. Simply calculating V by I and getting the mean value. And also here, you can check whether your practical is going well or not. Here, what you can do is, so we write Ohm's law as the potential current through a conductor is directly proportional to potential difference. What do you mean by this? When this potential difference is double, current should also get double. So if you double this, this should get double. And if you halve current, then voltage should also get halved. Now you can see here, for 0.6 ampere of current, if you want to get so much of current, you have applied 1.22 volt. Now, suppose you double this, say 1.2. You will find that this voltage is also doubled almost. The double of 1.22 is 2.44. But there are some practical problems. Whatever the instrument that you use may not be exactly calibrated. There may be some heating effect also. So by considering all such things, it is almost double. 2.44, 2.68 you have got. So you can check whether your practical is correct or wrong. Sometimes when you go for higher and higher currents, that suppose you do it for 1.6, it may not be exactly double this one. There may be larger changes because as you pass more current, the wire gets heated and it may not show the exact double value or half value or so. But somewhat you can check it. So that is how we can do this experiment. So for resistance per unit length, you have to draw the graph, whereas for resistivity, you can simply find out V by I and calculate it. So you can calculate all these values once if you take this. So you can take these values and you can calculate it once. Better you calculate it once yourself before going to the lab. Okay. Thank you. Then we will see figure of merit.